Good morning, everyone. Welcome to Spring Loaded, Reactive Spring by example. This is going to be part 2. After our talk last week, there seemed to be a lot of interest in a lot of things that we were doing. This is not going to be a self-contained talk. If you're going to view this in a video later on, or you've just joined for the second part, I do recommend you go back and see the first one because you won't understand much of what's going on. Okay, so in this, we have a couple of objectives. We have a couple of objectives that are a little bit different from last time because this is going to be by example. So by example means we're going to try out a lot of stuff. So I'm going to be doing a lot of typing. I hope everyone's going to do a lot of following. And essentially what we want to do is build up a really proper, good foundation for understanding Spring Reactive. In doing that, we're going to go over some basics. So first, we're going to go over the Reactive Principles again, just to get up to scratch for the rest of the talk, so to understand what we're doing. And then we're going to build towards Reactive. So we're going to go from the principles of Reactive. We're going to go and we're going to attempt to build our own reactive system. And then we're going to showcase a little bit of Reactive Spring's potential and continue a little bit on what we did last time. So it's going to look something like this. So quick recap, like I said, we're going to go through the Reactive Manifesto. We're going to understand exactly what was intended by the original ideology. We'll get the context of what we're doing, so a better understanding of the observer pattern, and you see exactly what this means to reactive, and then getting the observer pattern reactive in something similar to what Spring tries to achieve in their own implementations. And then we'll pick up where we left off last week. Event source reactive banking application. We will go over a bit what we went last week, hopefully with a better understanding given everything that we'll go over today. And we will complete it with a bit of a web reactive approach towards the end. Everyone okay with that? Okay? Change. Which part? Okay. It's going to be a lot of typing. I don't think it will be as long as last time's, so try not to sleep, hopefully. If you do have any problems or have any questions or anything, stop me immediately, okay? Sounds good? So let's go. So last week's Reactive Spring. We're talking about reactive programming and reactive systems. And we were trying to sharpen up our understanding of what reactive means. So essentially we want to think of reactive as a different way of thinking about our applications. And essentially it is going to push us to understand and implement a new paradigm. It's not just functional, it is also an ideology which goes along behind it. It is a philosophy. Okay? It is going to work well with immutability and statelessness. Immutability and statelessness being two things we greatly desire in concurrency. Last week we saw how many issues come out from shared variables, shared states, and mutating those between different threads. And it should be a no-brainer to understand how immutability and statelessness really appeals to a concurrent system. A reactive system and reactive programming should be message-driven and asynchronous. We're dealing with multiple numbers of streams coming from different sources. We're dealing with providing data asynchronously. It is message-driven. Really super important. That message-driven is a very big part and driving force in reactive systems. We do not just poll for data. We push the data and pull what we need. And we will see more about this push-pull mechanism a bit later. And essentially, the manifesto, which is how reactive programming and reactive systems are defined, define a number of things, which are basically responsiveness, which means we want data promptly, we want a response promptly, even though there is a lot of work happening in the backend. We want resilience, we want to be able to recover from errors, we want to be able to recover from things that have gone wrong and keep going, and handle them accordingly, not just lose data. We want to be elastic, which is the system being able to dynamically handle larger and smaller loads depending on what's happening in what data is being provided to it. And again, message-driven. Like I said, super important. We are event-based. Okay? Sounds good to everyone? This is just a quick revision from last week's. So, something a little bit important for this week. So last week, after having spoken to a couple of people, I sort of understood the fact that reactive and the change of mentality it brings with it, might be on a bit of a shaky foundation. We rushed through a lot of things, and I want to give a bit of a solid foundation to this particular talk. In doing that, I want to give a bit of an idea of the observer pattern. Observer pattern is a behavioral pattern, and it is really, really good for handling event-driven systems, or an event-driven paradigm. Essentially, what we want to do is implement something of similar ilk. I think the arrows aren't quite perfect, but you get the drift. So we've got an observer, and we've got a subject. Our subject is emitting events, and our observer wants to see the result of these events. Okay? Make sense? In these two classes, so this UML diagram over here, we're looking at the subject having exposing just enough number of methods to be able to track whoever's looking at him, so adding, removing, and letting them know that something has changed. And the observer literally just says notify, which is basically an update. This is the standard model of the observer pattern. Make sense to everyone? Seems pretty standard. Okay, so immediately we're going to get straight into trying stuff out. This is hopefully not going to turn into a game show where people just sort of shout out me missing out bits and pieces. So, I'm going to implement simple observer. Let's get into presentation mode. Yes, awesome. So this isn't going to be anything magnificent. This is going to be something that we've seen before. It shouldn't be. Let's just define a couple of interfaces. One for our subject, and one for our observer. Right? And we know that our observer should just do something like update, something like that, or notify. I think it wasn't, but we'll just do update. It's fine. And this is wants to add. So what we want to do is void add observer, passing an observer. We want to remove an observer. And we want to notify our observers of something happening. So in this, we're going to give it some args to pass on to our observer. Simple enough? No. So basically, now we'll just create a concrete implementation of these. So we have, subject, concrete subject. Oh. I remember how to do it. Awesome. And we have, bear with me on this, I know it's a bit boring, plus our concrete observer. Implements observer. There we go. Okay, so that's the basic done. So, essentially what we want to do is this. We want to keep in our concrete our subject, we want to keep a track of our observers. Observers. Awesome. Let's initialize that. There we go. Okay. So what add observer is going to do is add an observer to the observers list. Awesome. Remove observer, we'll just remove observer. Let's remove the observer. That's fine. And now the notify. So the notify means that we have an observer. So for all observers, string. Okay. This is fine. Each observer observer.update. Okay, we're going to pass the args And actually, obviously, when we want to update, we want to parse the args. So on object args, that should do just fine. Awesome. So object args. So let's just do something small with the args here. System.out.println. Let's just, for the sake of argument, get. Let's iterate over those, shall we? To stream, I think, yes, args dot each, and just do out and print line for that. Awesome. So we've done the function there. So that is our basic. So this gives us an observer and a subject, and the subject can register with the observer. The observer can register with the subject, and the subject is notifying the observer. So now all we have to do is just create a stream of events, right? So we just want to do public void main. Okay, bear with me. We want concrete subject, because actually we can just do a normal subject. Concrete subject. Okay. We want an observer. Concrete observer. Okay, that's our basic. So we want to create events. So let's just imagine we're going to start creating an event, some form of event stream. So let's just create a new thread with a new runnable. Ideally with the void done for us, but okay. Void run. Yes. We want to say, for example, just listen to keyboard events and create those. That's going to give us an infinite stream of events. So just have, don't do this at home. Sorry. Do you remember the scanner? It's been a while. This scanner, system.in. Okay. Awesome. So we just want a string input, which is going to be scanner.next. That's just the next one, that's fine. Okay. And what we want to do is tell the subject to notify its observers of input. Okay. Let me start this. Let's just exactly. Now the next thing we do is subject add observer. Astute. Yes. So this should work. We'll give it a run and make sure that everything's fine. So test. This. Awesome. So we have, in just a matter of a couple of minutes, we have just implemented an observer pattern. Super simple, super easy. But this, note the potential. Okay? Make sense to everyone? Okay. So let's get rid of this. Go away. So, back to reactive. So we've done the observer pattern. It's been a bit boring. We've seen this before. We've done this before. It's very basic. Fine. Back to reactive. Forget that for a second, just for a split second. And let's look at the reactive definition. The real pure, this is the way Spring describes reactive. A non-blocking, event scalable application that handle back pressure. Okay. In this there are difficult factors. Remember that reactive is not trivial. It is not just a matter of, okay, I've spent 5 minutes learning this. It takes some time. It takes a completely changed mindset, like we've been mentioning. So let's take this particular definition, because I think it encompasses everything that is in the Reactive Manifesto, and the people who implemented themselves are saying this. So let's break this down a little bit. So Let's look at the definition. So we go non-blocking, event-driven, scalable, and backpressure. Those are 4 separate things which are really, really important to the entire concept of React. So non-blocking, we're talking about asynchronous streams. We're talking about the ability to pass messages on in an asynchronous manner. Non-blocking, we are not stopping the flow of execution. Therefore, we receive events, we're able to send them again. We receive events, we're able to process them. It's asynchronous. Event-driven, push and pull. This is a question I was getting, in fact, last week. The reactive philosophy and the reactive implementations do not stick to simply push. It is both a push and a pull mechanism. Because the consumer, due to backpressure, the consumer is actually requesting a number of messages, and the messages are pushed to the consumer within a limit. So the publisher produces messages, and we consume at our own rate. It is scalable, dynamic, not that important at this particular case. It's just a matter of juggling threads in a correct way and making sense of what we're doing. And backpressure, flow control. Now, backpressure is something I stressed out a lot last week. We had an entire section on it. I won't go over it in its entirety again. But note the importance that backpressure and the effect it has on the event-driven section of it. We are going to allow the consumer to dictate to the publisher how much it should give us in order to safely consume a number of messages. This might still feel a little bit abstract, but we are going to do something a little bit cool. But is everyone sort of in tune with this? Does this make sense to everyone? At least until here, does it help sort of clarify a little bit on what we're trying to work towards? Yes? Cool. Guys in Serbia, everything okay?
Yep.
Okay, awesome. Yes?
Between reactive and the observability pattern, the observability pattern is only a push pattern.
Ideally, yes. In its core, yes. The observer pattern would be just a push.
Different which are the push and
Exactly. In fact, Spring themselves say that they are an extension of the observer, sort of extension in inverted commas, because there are a lot of added complexities on it and a lot of touches and things like that. But they actually do say that they are an extension of the observer pattern. So with that in mind, let's relate the two a bit together. So we're talking about publishers and subjects interchangeably. Between the observer pattern, we were talking about subjects. Now in Reactive, we're talking about publishers. We're also talking about observers and subscribers somewhat interchangeably. Also between the two styles, and like I said, performs push and pull, which is something a little bit different between the observer pattern. Now, we also need an additional middle ground to handle backpressure. So we're going to be able to make some modifications to the observer pattern to shoehorn it in a little bit into the reactive system, and we'll adjust something in between. So when doing that, take a look at this. So we have a publisher and a subscriber to one different point. Subscriber is going to subscribe with the publisher. The publisher will notify the subscriber of the subscription and form a subscription between them. Okay. The subscriber requests through the subscription from the publisher. The publisher waits for that to happen and checks before issuing an event. Once there is a request available, we can send the event down. The subscriber consumes it in its own time and then requests for the next one. Request for the next one, the publisher is waiting, and then it sends the next one on. Gives it to the subscriber can work with it in any way it feels like. In the meantime, it hasn't requested anymore. So if another event comes to the publisher, it will wait over there. The publisher is waiting till the subscriber tells it to go forward. Subscriber, like before, requests again, publisher finds out the request is there and passes it through. The last thing it does is it will close the stream. Slowly, it will get there. Slowly, yes. And there. And we send a complete. Okay? Make sense? Okay. This is going to keep repeating. So, what we're going to do is we're going to make modifications to our own observer pattern and try to create our own reactive way. Okay? So bear with me on this. So, let's do some. No? No. Right. So, first things first, let's do some change in naming, yes? So, our observer is now going to become our subscriber. Okay, our subject is now going to become our publisher. And we're also going to change some things around. So the add observer now is going to be subscribe. Subscribe. Yes. These are not going to be so important for now. We'll leave this one for now. Actually, no. We'll remove that entirely. So just keep a nice, fully clean publisher. Our subscriber is going to grow a little bit. So our subscriber is going to have, instead of updates, we'll call this on next. Okay? Then we're going to add a couple of methods to say on subscribe. So to have a bit of a call, something for the publisher to call us and let us know that the subscription has been correct, and for the publisher to actually give us something back called a subscription. So we're going to need a subscription itself. Subscription. Yeah, if I can spell. Subscription. That's right. Thank you. Thank you. No. So we have a subscription, and our subscription is going to be responsible for handling the request part. So like we saw in the animated GIF, so beautifully animated GIF. The subscription is going to be responsible for knowing when our consumer or our subscriber can actually handle even more. So for that, we're going to create a method request, and inside it, we're going to give it a number of items. Okay? Super simple. Nothing too special. So here we're going to pass through the subscription with name subscription and super dandy super high. Okay? Makes sense? Right. So we're going to make some modifications. The remove observer for now we're not going to handle, not too handy, and this we'll use in a different manner later. Okay. So.
Chris.
Yes.
Why now we're having publisher method subscribe?
So the publisher method subscribe is the same as before, what we had as add observer, which is something pretty much core to the observer pattern. It gives us the ability for a subscriber to subscribe to the publisher, and the publisher to do some work on that.
Okay, continue. I'll see if I...
Yes, don't worry. Stop me if things stop making sense, okay? So, to make things a little bit simple, I'm going to remove this as a list. So I'm going to just keep this as a subscriber. Okay. And what I'm going to do is this dot observer equals observer. Okay. A bit of a hodgepodge of naming here. It's a bit annoying, right? But remember that what we were talking about before, subscribers, observers, same thing, okay? So I'm going to change the naming in this, but don't let it confuse you, okay? So, subscriber and subscriber. Okay. So then now, this is pretty much what we had before, okay. So this we don't need anymore, and this is going to be our only subscriber, and that's dot on next. So this was literally on its own. Our publisher is pretty much ready. Okay. So one more thing that we need to add, which is a little bit different from the vanilla observer pattern, is that we have to add the subscription. Subscription needs to be able to understand how the publisher is going to be re-triggered or be told that there are more messages to be sent through, that the consumer or the subscriber is able to handle more. So let's create a concrete subscription here. Concrete subscription. Implement subscription. Okay. Subscription. Does that create subscription yet? Yes, subscription. No, doesn't like it. Of course, this needs to be This needs to be a class. Complete. Yeah. Aha. Wait. I grabbed the wrong one. Subscription. Concrete subject. Concrete subscription. Yeah. No, it doesn't matter. It's fine. Actually, I don't want it to be static. Because what we're going to do is create. Do you guys remember about the types of variables and concurrency issues that we were talking about last time? So we're going to create a volatile long and called Q. Yes. Very good. And this is going to be taking keeping account of how many items our consumer or our subscriber can consume. Okay? So that means that during our request, we can take the queue and plus equals 10. Make sense? And before notifying, I want to make sure that if n q is 0, we want to wait. Okay, so one of the ways that's quite easy to wait is to say to add a lock on the subscriber and say subscriber.wait.
The queue is the number of messages the publisher has, or
the queue is something that the publisher understands. The queue, the publisher must know that the consumer or the subscriber cannot handle anymore. This is one way that we can implement it. This is a similar implementation to, I think, the push publisher implemented in Java 9.
The queue is the number of messages which
we can provide to the consumer, to the subscriber. Okay? Remember, at this point we are in a concrete subject, or rather, let's make this a concrete publisher. No. Just like that. Okay? So we've overhauled our publisher somewhat. Okay? But that's something about it. So at the same time, we need to make sure that if we do continue, after notifying, wait, subscribe, and on next. So we want our queue to go down and make sure that it doesn't hit 0. And when this is increased, I have a synchronized lock on the subscriber, and it said subscriber.file. So that unlocks everything for us on the request. Okay, but this is a little bit of a mishmash. I'm going from the bottom up, bear with me. Now, we've got our publisher pretty much done. We've got to go over our subscriber. So our subscriber at this point is
Заебался, составил смайлы. Видос это ты уписываешь.
Okay. So, remember that the subscriber is going to take on some methods which are responsible for handling this entire chain. So with I subscribe, the publisher lets me know that the subscription has succeeded and I can start some work. And then I need to let the publisher know that I can accept some data and things like that. So the next link in the chain is to say that on subscribe, i.e. after we have subscribed to a publisher, we want to do some work. And that work needs to be to let the publisher know that we can accept data. Okay? So, in doing that, what we want to do is, first of all, keep a track of the subscription. Okay? So this dot subscription equals subscription. Okay? And what we want to do is let our publisher know that we want to accept more. So the subscription dot request. And here we have to give it a number. So the subscriber is free to choose. Let's give it 2. It's free to choose. Okay. the number of items it can accept at any one time without it failing. In other words, we will tell our publisher to give us just 2. Max Q, just 2. And this will ensure that we are fine. At the same time, we should keep track of how many items we have consumed till now in this particular session. So we'll create our own queue. Long queue. And this is 0. Okay. So on subscription, our own queue becomes actually we're going to leave it like that. Yes. Okay. Now we're going to be consuming data. Every time we consume more data, we're going to shall we decrease to 0 as well like the other one? Yeah, why not? Let's keep a uniform behavior. Includes max Q. Okay. So our Q is going to decrement each time we do something. If our Q is 0, we want our subscription to request 1. And we initialize our queue. Okay.
What if the publisher only has 1 cent?
Then it will remain pending, and it has an ability to push whenever it has data in hand.
So if you're requesting 2, it will send you 2. It won't send you a max of 2. It won't send you 1.
It will send 2, and then I will let you know whether you can send another 2 as a subscriber.
Send 2.
Yes.
It's in 2.
It's not like
Okay.
You want 2 packets at the same time all the time.
So the stream remains, so you remain under the, but it doesn't have to be, sort of, it won't fail if 2 don't happen at the same time. If you have 1 at one point, 1 at another point, as long as the publisher gives us 2, and then we'll let you know whether you can give us another 2. Kind of thing. Okay? Okay. So we're making a lot of modifications, but bear with me. Okay. So let's produce some data. I think as it is, if it is not perfect, I do apologize, but I think it's about right. Okay. So something like that. So ideally what we want to do at this point is produce a number of events. So this won't do. Let's produce something every, say, let's produce a counter, shall we? Counter equals 0. Okay. And this has to become a concrete publisher. Publisher and concrete publisher. Why? Because now at this point, concrete publisher. We need to know exactly what method is. We need to trigger within the publisher to let its observers know. Unlike the traditional vanilla observer pattern, the publisher and subscriber patterns do not enforce a method by which you call, because the publisher itself might be handling the data in different manners and things like that. The guidelines by which this particular publisher and subscriber relationship and implementation is done is very, very loose. And I will show you exactly how this is manifested in Java 9. But for now, let's just keep it this way. So we want to produce some data. So let's say, let's not produce something immediately. So at least once every millisecond. We'll just sleep for a bit, and we will send our concrete publisher to notify observers, or I'll change that later, about our counter. Make sense? That's there, and our concrete publisher dot subscribe our observer. Yes. So let's get a bit of an understanding of what's being called when and how. So. Let's get some logs. So over here we're going to call a request. Okay. Let's actually add the queue size as well. Okay. And we'll do an on next as well. On next call. Okay. Okay, we'll add a little log here as well. On subscribe call. Okay. This will give us a bit of an idea of how the flow is working. Request called. Subscribe call. Subscriber and subscriber code. Subscribe code. Okay. So I have a subscriber, and now last thing we want to do is subscribe everything. So this dot subscriber dot unsubscribe, pass a new instance of our subscription. New concrete subscription, and that there and subscription. Awesome. Make sense?
No, one of this is a good point.
So this is part of the link chaining that is expected of the publisher-subscriber relationship. So here we are in a concrete publisher.
The publisher creates a subscription.
The publisher creates a subscription.
I thought it was the subscriber creates a subscription and sends it to the publisher.
The opposite way. The publisher creates a subscription and sends it to the subscriber. Why? Because
The subscriber says, "Yeah, I want to subscribe with you," and
exactly.
This is your subscription.
Exactly. Because the subscription provides us with an in-between way of the subscriber telling the publisher, I want more data. And so the subscription has to speak to the publisher to tell it, provide me with more data. So this is the relationship which is going to permeate through. You see this working. So.
So the data is sent through the subscription.
The data is sent directly to the subscriber from the publisher. All that's being controlled is this push-pull. So all that's being controlled is the back pressure here.
And the back pressure is
what we're going
by the subscription.
Pretty much. Through the implementation of the subscription, we have given it a mechanism by which we tell the publisher how much to give us, and the publisher can be updated on how much to give.
So the subscription instructs the publisher how much the subscriber is allowed to take, and the publisher then pushes the data.
Exactly. This is implemented in multiple ways. There are some people which implement generic subscriptions and then the publisher handles it and all these things. I'm implementing a particular methodology which is a bit decent to follow. If you do dig into Spring Reactive Flux, i.e. publisher, implementation of publisher, and Flux zip, Flux thing, and go to the Flux stuff, it is not trivial in the slightest. You will not find them to be so directly related. But you will find the subscription defined within the publisher, which has visibility over the publisher's queues and synchronizes between the variables there for the publisher to send data out. Just very, very convoluted manners. This is something similar to implemented by Java. An extremely basic way of implementing a publisher subscriber. Exactly. Okay? So it's not the only way and the main way. Okay? But in doing this, we should at least, so let's build the subscriber into the first sequence. We should have enough data to see the first sequence. Subscribe calls, unsubscribe calls, and request calls 2. So this is going to be our initializing chain. When a subscription subscribes to a publisher. So when a subscriber subscribes to a publisher, this chain is invoked. Subscribe called, unsubscribe called, unsubscribe is at the bottom.
Subscribe is the callback on the subscriber.
Actually, let me help this out a little bit and say where we are. Let me help this out a little bit. This is subscription. This is subscriber. This is subscriber. Now this. Make sense? So this is exactly the chain we've been talking about. There are these three little steps. So the publisher, so a subscriber calls subscribe on the publisher, where we get the log line publisher subscribe code. This is our first bit. Now the publisher is going to create a subscription, pass it on to the subscriber, and say unsubscribe code. And the subscription, and when we do unsubscribe, the subscriber is responsible for calling the request. So request called, and passing our maximum buffer or the maximum number in queue. Okay? Make sense? Did I lose everyone? Or? Sorry? The subscription in the request method. The request method is in the subscription. Request? Is this what you're looking for? Concrete subscription line. Yeah. There. Yes. So this is going to modify the queue size on the publisher. We emitted this log, and we're going to let the publisher know that the subscriber is ready again. So anyone who was lock waiting over here when on notifying will be able to handle it. Okay? So ideally, we will do while queue is here. So that if when we come out of this, someone has managed to get the handle with that. There's a lot of synchronization stuff here which I haven't implemented just yet, but you'll see it happen in a minute. Okay? For now, we're just going through a blocking way of doing this. Okay? Make sense? Oh, kind of, I guess, right? Okay, alright. Let's see if we can emit some stuff. So, let's make our subscriber do some work. So, let's spin lock. So while we have a counter, I equals 0, this is going to buy us some time. This is going to pretend that we're doing some work. So while I is less than, say, 500, 5,000, whatever, something like that, I plus plus. Okay, this is going to pretend we're doing work. Okay, so let's emit some stuff. Let's go back to this. So we're going to start a new thread, which is going to start emitting stuff let's give it a couple of milliseconds. We're going to notify observers about the counter. Okay, makes sense? I think this should work.
Can you go into notify observers?
All this is going to do is do some work to say, okay, I have an event. Who are my subscribers here? Should I send this event to my subscriber? If yes, just call on next, and I send the event. In this case, then the event is going to just be an arbitrary argument, just a silly parameter, but it will in the digits. Let's see. going up and down the queue immediately here. There is no waiting involved because we are consuming as fast as we can produce. Fine. Let's see what happens when we increase, but that obviously that's blocking. So, if we want to be non-blocking, we need to make this asynchronous. So, making this asynchronous, we are going to need to, our publisher will give us data. Publisher. We're going to create a thread pool. Actually, just a thread. Let's do this. Our publisher will give us data in a non-blocking manner. So the second it does this, it will do all this piece in a new thread. You're runnable. Okay. Don't let this lose you, okay? It is just a matter of sending the event in a different thread. So this is no longer this. Now let's try. Now let's see. Nothing we couldn't try to. Now. Next code, next code, next code, next code. I must do
the counter you implemented. Shouldn't you be checking that to make sure that you're receiving too?
So on receiving, as a subscriber, well, I will run this. Okay, so I receive 1, but I have a queue, and the queue is being reduced each time. When my queue reaches 0, if I can take more, I will ask for more.
You will ask for, okay, that's right.
Okay?
Oh, yeah, so I could figure out. Okay.
So, I think I'm missing a piece. So. Or consuming state from exactly. So now we've got in a waiting state. Fine. Why? Because obviously this is going to take long to do. Let's try and make this at least reasonable.
I'm actually interested for this optimization. So this is variable you're repeating, this is variable you're implementing, right? Java sometimes has a tendency to actually remove the statement altogether if it's a set of things.
Well, there is work being done over here. What it would replace is on the outside then.
I mean, the I is not being represented as a variable.
Same as doing this, right?
No. I mean, like,
The photo.
I would have expected Java to optimize that out, that line.
This would be a spin lock. So I think something like this should give us a bit of waiting time. Does it give us an unlock? No. Essentially what I'm trying to do here is this. So we've got a state where we're taking long to do some work as a subscriber, right? Now, what's happening on the other side is that the publisher is waiting in line to be told, yes, it's fine to go ahead. Which means that we have forced a wait on the subscriber, and that this is going to be done while the queue is 0. So I must have left something out. In the concrete subscription, on subscribe, concrete subscription, where are you? Here we go. So, queue. Say, that's being sent by this emitter up here, which I have created.
Go to where you're requesting again. sorry, no, further up.
So the request is happening by the
Wait, hold on.
concrete subscription and concrete subscribers are looking for on next. Yeah. This is where the request is happening. SQ is 0. So what we're missing here is this. What is this? So what's probably happening is this is ending up below 0. Which is okay. I have another example instead of this, so don't waste time because we're already nearing the end. Okay, let me just so bear with me, I'm just going to replace everything we've done. Exactly. I must have missed a single line, but can't. And we'll comment everything. So, okay, so this should be already set. Very, very similar to what we were just doing.
Presenting
So here the log isn't as pretty as it was before, so let's just add some logging in it. Show our file. So subscribe. So publisher. Okay. Side. Okay. Concrete. File. So request code. Subscription. Request code. And we added our N. Oh, sorry. Our Q. Okay. And yeah. On next code. So we've got system that out created now. Actually not. On next code. Same spin lock, has a bit of a sleep in between as well, and provides its request. So, right, unsubscribe. There.
or synchronized block over there.
So was I missing a synchronized block? Yeah.
I think yeah, the next one, a couple of lines after.
Okay. I think this would give us inkling as to what's happening as well. So we've got a typical subscribe call, unsubscribe call, and request call, and this one's providing for. I have on next call 4 times. So I have on the publisher has provided us with 4 different events, and this is now waiting. This is the result from our subscriber of what the publisher has given us. And again, we're waiting. Subscription request called for 4, and again waiting. We've provided another 3, waiting, and 1 more. So you see, there's this constant flow coming out of going, I have data, here, take the data. I'm consuming the data, you can wait. as a publisher. Do we get this kind of relationship? I think I must have missed literally a one line. So everything that is in this code is exactly the same as you saw before, and I would provide it to anyone who wants to see. But this is going to describe our publisher-subscriber relationship. Okay? Makes sense-ish? I know I went up and down code and refactored a lot of bits and pieces, but through this, I think it's a bit of an understanding that we are going through of how the observer pattern relates to the reactor implemented stuff.
You said that the publisher notifies the subscriber that it has data sent in.
No. The subscriber notifies the publisher that it is ready for data.
Okay, but I misheard you, correct. I thought you said that
once you have the data, it pushes it straight onto the subscriber using the onNext method. Okay?
The subscriber who is requesting data.
The subscriber tells you, I can request data. But then the publisher pushes it within a limit. Push-pull. Yes?
And if the publisher then we request this for the publisher has the date, it waits until there's like 40% then sends them, right?
No, it sends them all. It sends everything it has now. And when it gets the fourth one, it doesn't have, it just sends it straight through. It doesn't have to wait for the subscriber to tell him, I can accept data. Because the subscriber has a token I will take for just fine. Yes? Obviously, the implementation of how to accept data and on what kind of criteria is entirely dependent on what kind of subscriber-publisher relationship you would like. If you take a look at RX Marble, you will see how these kind of combinations will happen and how you want the relationship to be. So you can accept immediately, you can accept one at a time, you can accept different ways. We have just implemented a very, very simple single publisher, single subscriber. In reality, you have multiple publishers. Subscriber will see an aggregate way. You can have a publisher and is a subscriber, as you will see later on. I forget the time. Hopefully 15 minutes more and we'll get that. Sorry, I'm taking a bit of time. So, but we get a bit of a gist of what's happening here, right? Hopefully. So that's implemented all of that. So in relation, take a look at how Java 9 is implementing it. This is how Java 9 is exposing its interfaces. This is the interface for the publisher with just the subscribe method. This is the interface for the subscriber, offering an on-complete, on-error, on-next, and on-subscribe. We didn't bother with the on-complete and on-error. It's not that simple. On-complete is when the publisher has completed sending data. It has nothing else it will send. Okay? So it wants to close the relationship between it and the subscriber. It says on-complete. Everything is done. And on-error is our way of handling, is the way of handling. Okay?
So the publisher calls the on-complete subscriber to notify that no more data is going to be...
Exactly. But we have used the on-next and the on-subscribe. And we saw how sort of the publisher calls the on-next and everything goes well. And this will be the subscription. The subscription literally has just cancel and request. That is all its methods. Reactive Spring makes use of this. This is described as a service package interface, if I'm not mistaken, an SPI. This is not meant to be used willy-nilly in the way we have just done. It is because this is non-trivial, and by the vacant faces, I assume that 90% bad explanation and 10% difficulty. This is not an easy matter. You have to flip your understanding of this. You have to understand the observer pattern super well, and you have to understand what is attempted to be achieved, what is trying to be achieved here. Keep this in mind. We want to achieve asynchronous, push-pull, dynamic, and flow control. With those three interfaces, we are able to perform all these. Because of the observer pattern, we can do an on-blocking asynchronous push-pull messages. We can provide at least those two criteria. And back pressure with our subscription because it will notify our publisher on how to go forward. Okay? But in a nutshell, within, maybe about a half hour's worth of modifying our code, we were able to achieve something close to a typical reactive state, which is not bad, considering that this is not a small concept. With that done, let's just quickly pick up where we left off last week. Something small, just a quick reminder, we are building towards an event-sourced application, using a functional paradigm, and using our Spring Reactive data and web. Let's give it a second shot. Very quickly, I'm trying to go over this fast as possible. So, this time, we will get out of this one and go into our TPM. Because now we will need Java 9. Also, please note, nothing of what was done of the observer part that we have just discussed about was nothing in Java 9. Everything is Java 9. Okay, now. So. Let's just pick up quickly where we left off last week. So last week we ended up with this. We have a way of generating data and an interval to slow it down, and a way of getting the two streams together. Now we will understand a little better, hopefully, the nature of subscribing to the stream of data, performing some work on it, and subscribing again to the result. This is in a reactive manner, but to all intents and purposes, this is just calling back this on event trigger. This flux.zip is both a consumer, is both a subscriber and a publisher. In Spring Reactive, you'll find a lot of these, especially when you are joining streams together. Streams of Flux, each one of these are publishers in themselves. With this, we are joining a publisher and becoming a publisher as well. A bit difficult, maybe it's a bit convoluted, it's a bit Inception-like.
Or are we creating a new publisher from other publishers? So from other.
We are creating criteria for us to subscribe to multiple publishers. And as a subscriber to these publishers, we are also creating a publishable stream for someone else to subscribe to. So this is exactly what has happened. So in here, internally to the .zip method in Flux, I'll try to dig a bit down just to be able to see some bits and pieces of it. One of these will be implementing, in fact, I think, taking a publisher. Like I said, these won't be super trivial, unfortunately. I'll try to dig as deep as possible. But this is going to basically be it. This isn't going to be very helpful. No, let's leave this out. But if you dig deep inside, if you dig deep inside, you start seeing the same signs of what we were working on ourselves. So subscribers, publishers, a subscription in between, and work being done. Okay, and then it has a by consumer, I think I'm not mistaken. Spring produce a lot of interfaces of their own and create these kind of two-tier kind of subscriber publisher kind of things. Okay, but essentially, this is all we're doing here. Everything that we have spoken about is in here. Publishers, subscribers, subscribing, everything. And we end up with this final result. Let's give this a run and remind ourselves what we are achieving at this point. I have saved. That's the timestamp. Okay? So here we have an infinite amount of events being triggered and saving into a Mongo database. So, to reiterate, we have also a document called transaction, which holds IDs, an account name, and an amount, which we are generating and saving to Mongo using a repository under the Reactive CRUD. The last step is to retrieve that data. So we have used Reactive Spring data, Spring Reactive data, Reactive Spring data, and now we will use Reactive Spring Web. Now Reactive Spring Web allows us to use Flux and Mono, which are our two publishers, for publishing either a number of items or one, in a web context. So when doing that, we're just going to create a class, which would be a transaction control. And this is a REST control. Okay. Create a constructor to just pass through transaction control. The package of the controller. This. As far as I know. This should be box standard. No, box standard. Okay, and we'll just pass the repository, transaction repository, transaction repo, create transaction. This is all stuff that we know. Transaction repository, okay, and this dot transaction. Cool, super cool. Next, the last thing is, at least let's create one endpoint of type flux of transaction. Transactions. Okay, this is going to return this dot transaction repository dot find all. Yes. Now, for the simple sake of not spitting everything out and closing the transaction and seeing how it handles streams of data as it goes along, let's do the same as before and create an interval. So before, what we had was a simple flux of type long, which was a flux interval, equals flux dot interval, and of duration of seconds of 1. So at least every 1 second, it's going to allow us to do this. So with the find all, we will produce, we'll do flux.zip again. Sorry for using the same stuff, but this is the easiest. Flux.interval, flux interval, find all, and that dot map, and we get tuple 2, get 2, get. Okay, so this is going to give us a flow stream, an outgoing stream of data, which we know exists and has been persisted. So at one point we're going to be persisting, and at the other point we're going to be retrieving. So to be able to do this, we need to annotate here. So we have a get mapping, simple get mapping, which produces. This is important if we want to get a constant stream. Sorry, media type of type. Media type. This dot text event string value. So fantastic. This should do the trick. So Shift F10. Let's see that everything has worked. Okay, so we're getting events there. In the meantime, what we're going to do, shortcut for this, what we're going to do is showcase potential of this. I'm going to open a simple terminal, and we're going to simply curl HTTP host 18080 HTTP host 18080. I think it's just like this. And we have a stream of data that goes in and comes back out. Some of these are going to be from last week, but it's going to keep providing us data immediately. As it becomes available to it, it becomes available to us, until it has no data available left to give us. In other words, if this flow of data was faster than we can consume it, it will just keep giving us data.
Can you zoom in again? Go to presenting mode.
Which part?
Presenting mode. The code, the endpoint.
Is there anything in particular? Maybe? Yes.
Oh, it's like having what this way so the data gets studied.
Similar, but yes. But not in this case. We have data entering a database which is not yet finalized. We still have literally a generator creating data, and we are consuming it as it's being made.
So it should be another application, or you manually fire up a Mongo, press it into the database?
Yes, to all intents and purposes, yes. In this particular case, for example, I have slowed down the consumption of it so that we can ensure that we keep the stream open to Mongo, and we keep consuming data.
Exactly. Once we've received all the Mongo data, call it done.
Yes.
Right.
Yes. But if, for example, in this particular case, we have created something which...
The find all it would execute it once, keep it in memory, so literally, right? What's gone wrong?
It will not execute it once, it will just keep it open. That returns a flux.
It returns a flux.
Find all in reactive, because remember, we are using reactive CRUD repository.
Yes.
I can get that. No, that's not very helpful. What was that? This returns a flux of transaction. A flux is a publisher.
So what is it?
And all match everything, I guess.
Find all matches everything, but it also gives us a way to just constantly get more data from the database.
So control that.
What is doing on the database? It's not a query, no?
Not in the database, I'm not 100% sure. That's by the driver. I didn't go into that. Sort of feel free to dig deep in.
Very, very strong to the database. I mean,
I think it just keeps a connection open to it, but because of the way the Mongo drivers are written, I don't think it's taxing. I don't think it's particularly taxing.
you keep the streaming connection open to the database.
Yes, you keep on, yes.
One for request.
Yes, but in this particular case, keep in mind that the database is being worked on as we speak. We are working on data from the database as we speak, and in this particular case, we don't even need the data to be final. So as the data is being created in the database, it is ready for us to use as it goes along. As multiple flows happen, we are able to use that data immediately, right off the bat. So we are incredibly responsive.
Why is it sending? Why isn't it always sending the same data?
I think there's some management driver probably to actually keep going.
Continue.
I'm sure it's
presumably, yes. There is driver handling of how it goes and then go and doing the
reactive the driver needs to be reactive. And that's the most important thing. There's already some implementation from SQL as well, but that's not official. So the driver needs to handle this type of flow. So the good flow. The right data.
Yes.
Then before we stop anyway, then quality will stop writing. What would happen in the area being to have the people of the data?
Actually, coincidentally, that is exactly what has just happened. So we stopped writing data to the database. For some reason, it was this one. I'm not sure what happened, but something must have stopped it. And curl stopped. That's it. The flux is closed. The last thing received. No, must have done something else. In fact, this is gonna give us everything from the very beginning. But either way, the last one is the last one that we have persisted.
There's one in the logs as well?
Yes, that is this. So in other words, we have opened a stream to our database prior to these things being created. Until they were created, we were then finally able to receive them without stopping our work, without going back to the database and going, "Well, do you have anything new? Do you have anything new? Do you have nothing?" It's just straight through. Goes in, comes out, we process, we can do whatever we want. We're incredibly responsive, it is asynchronous.
Yeah, it's the voodoo behind the drivers.
Well, the voodoo behind the driver is...
Even for state, we are using a reactive repository.
Sorry?
Saving data.
Yes.
What if you just write data on the database? I mean, is the to notify who is doing the query that there's something adding data? Or let's say now you run a query on Mongo and add a new row. Is it visible to the Flux stream?
Once it's closed, no. once the Flux stream has been sent the uncompleted, which means that there was no more data persisted and no more data changed.
So what's the use of a Flux save?
If you can save data slower. And like we are doing, for example.
You can manage flow control on your tape or on whatever you're going to do. It's still the same pattern. So whatever you can get, I mean, the benefits of all reactive stuff, save or do whatever action you want to do.
I know it's a bit heavy, it's a bit convoluted at times, but if you do want to take a second look at how we've implemented things and take a look again at what we're trying to achieve and what it's achieving, you will suddenly start seeing how Reactive Spring works. So if you've got the subscribe, it's asking for data, and there's many data items as it needs. So for example, the zip wants one data item at a time because it needs to combine them together. If this is going to provide us with one, we're going to be waiting for this and nothing else will generate.
Okay, come again.
So, actually,
Zip comment, you need two sources.
zip needs two sources, but it waits for one at a time. So it doesn't tell its sources to give it 500.
It asks for one and then asks for one.
Honestly, I think it asks for 8 if it's slow, because it has some throttling happening, if I'm not mistaken. I think it fluctuates between 8 and 16 at any one point. The way they implement it entirely. It is entirely up to whoever implements the publisher or subscriber. Entirely. These are publishers.
Can you on top of this?
This what to do. It will merge the two streams, right?
Yes. Yes.
So it will take some time part of one stream and then switch
Exactly.
to the next stream.
Exactly. But what I mean is that it's taking pieces.
Two, right? In order to send, to publish again.
You have to have 2. Yes.
What's the tuple two?
The tuple is just the output of the zip. The zip creates a tuple of, it combines them into a stream and to a publisher, but of type tuple. So this.
Basically, we're taking the second value of, like the value of the second stream, and not the first stream, because basically it is joining the two streams.
Exactly.
But
Basically.
we're saying, okay, let's take the value of the second stream, in this case, not the first one, or both together. But at every time you know the value of both state spaces, and then you can just do whatever you want.
Then we see the response from the browser console.
Yeah.
We don't need the time with the information I see.
Sorry?
What is your response?
No.
The sense, for example, to the browser.
You mean the response code? It's just waiting for the...
I haven't tried actually. Let me give it a shot.
Because from
But the
card,
thing is,
it's okay, you are just giving data. But from a browser,
I think it would look like
Not 100%.
being replied upon flow.
yes, but you're receiving data. You are not
Yeah,
waiting
yeah.
for the one packet, you know.
Let's say you request a link page, and the server can only send 1 kilobyte per second. You will be receiving the flow.
Might be specified
The network.
specific media type. It's not application JSON of the text HTML, you know. The stream.
Like what you use for uploading a file.
Okay.
I try 100. Okay, I know for sure that Chrome handles this better because this prompted me to download the file. But Chrome handles this as a proper stream and starts it iterating. So I'm trying to install Chromium. If you give it maybe a couple more seconds, I'll have it in hand. But browsers do handle it, but not all of them. But that's why I used curl, in fact. And in fact, even most demos use curl straight away, because obviously you don't have to stay faffing around with it. I'm not sure if there is a command to show response headers in curl. Perhaps Clayton, you'd know. Not offhand.
HV may be verbal.
Possibly. I lost it. Pinky, HV. Yes. Accept, get, 480. H200 okay.
Just a slow response, I guess.
Response.
So the body is actually streamed. The header,
Yes, yes.
header is to the request straight away, but the body is streamed.
Yes.
Instead of waiting better, you can start, for example, the UI might already take action and start doing stuff on the UI, or not wait for them.
I think this stopped because I gave it a date range, right? Yes, that's why. This is why it stopped, which is fine. Because I gave it a range. Makes sense, guys.
Magic.
I would hope at least after the run-through of the observer pattern and the reactive observer style might have removed a little bit from the black magic happening under this.
Exciting black magic.
Sorry? Exciting black magic. Guys, is there anything maybe that I can help with, or perhaps you'd like to take a look at before lunch? Yes, of course, definitely. All of this will be shared, and also the references that you can read up, and some code samples, maybe a little cleaner than mine that I did in the past.
Are there any of the talks online?
Yes, I think if you look up...
Didn't do them in email, is it?
I will. There is a similar example to on which this is based, where they use it for, I think, Flux, they call it, which is like a movie streaming service kind of thing, in inverted commas, which basically they implement just a couple of endpoints in the same manner, exactly the same thing. And yes, something I wanted to mention is you can do all this in a functional manner. I didn't do it because unfortunately I didn't manage to achieve it, but it basically looks like something like that. So instead of setting the at-rest controller and all the endpoints, you set a root head.
Again, the controller is a regular Spring controller. Rest controller, just the media type.
Sorry? So the function is, one sec. So one sec. So the functional is this. So you can replace the entire REST controller and all the annotations and everything simply by using a router function. And this will be entirely functional, and it returns root.
Yes, for sure.
Okay? And you can chain it. So root, accept, and pass, and OK, and response, and things. And that grows. And you can see samples of that, and I will provide it. Now, you wanted to see the REST controller. So this is not Spring Reactive.
This is the Flux Transaction.
Yes, this the return type is a Flux transaction. It's important. And similarly, if you want to provide a mono transaction, is also accepted. I just did it this way, sort of.
What's the difference with Flux and mono?
Flux provides many, and mono is used as a publisher of one. It is expected to be. So you get all the bonuses of using .subscribe and everything that comes along with it, and you can combine the mono with the Flux and things like that with different ways.
Like, give me one when it's available.
Exactly. Give me one when it's available. Yes. That's the mono. But this is the Fluxes give me many items when they're available. And since they are asynchronous, they become available and give it to me immediately. Yes.
Debugging. Are there challenges or? Because I mean, data changes while you're waiting, or
because these are immutable and stateless.
So
yes, but
sure that sort of you're at your current state without thinking.
But you are not changing state within there. Thank you. You're not changing state when you're within it. Sort of, you are modifying data and producing a result, or retrieving data and producing a result. And so, sort of, the debugging of it isn't savage specifically because of Flux. It is just typical functional programming debugging. That is the biggest headache as always. But everything else, you're just manipulating streams and putting them together. And guys in Serbia, would you like to ask anything? We're drawing to a close. Or maybe everyone went to lunch?